Physics chapter 22, theory video 2. So we are going to look at the practical activity 22.1, that is investigating Coulomb's law. So we we know we know that this is an inverse square law. What we do is we have to, it is not practically easy doing this experiment for various reasons, mainly because we can't actually retain this charge for a considerable period of time as it is, because we tend to lose the charge. The charge is lost due to different reasons. Usually it actually leaks out. Charges tend to flow. So this will be lost to the air or the whatever the other things that that is in contact with. So what we need to do is we have to make sure that they do not touch any conducting material, and also when we make it into spheres, the loss of charge is also minimized. So then the forces, because the amount of charge we can store is also usually small, and it is difficult for us to measure using any equipment. So as a result, we get only a tiny force. So here what we do is we have clamped up silver polystyrene balls, that is polystyrene balls, that is rigiform kind of balls we take, and then we coat it with silver, conducting silver, and when we give it we have them positively charged, both of them, and they are connected to a perspex handle to make sure that it does not lose its charge. And then when we bring this what we do is we bring this these two balls together. We push the below one closer to the bottom one. Then what happens is, because these are two positively charged balls, what happens is they will start repelling each other. As a result, the measurement on the scale would increase slightly, giving us the confirmation that there is a force generated between the two. So this is when you bring them closer, what happens is, because of the inverse square law, the force increases. So that can be measured, proving the law, that proving Coulomb's law, and giving us the idea that Coulomb's law is in fact correct. Then moving on to the next topic, electric field strength for radial field. So so far we have learned that electric field is defined as the force per unit charge exerted on a positive charge placed at that point. So you can remember there is a field. In the field we place a positive charge, and then in that what is the force that is exerted on that is what we refer to as the electric field strength. And we found that it can be calculated using the equation E equals F upon Q. Then to find the field strength, if there is a point charge Q1, what we do is, this Q1 is either it is near a point charge. Point charge could be a single point or a uniformly charged sphere. We know that it acts as if the charge is stored at the center. Then we think about another charge, positive test charge of Q2. So the Q1 is the point charge, right? Then there is a Q2 charge placed in the field. Then so if you are confused about that, so this is Q1. So it would have charge, let's say it is radial field. So there is a radial field like this. And then what we do is we place a Q2 charge somewhere here. Q2 charge is somewhere here. So something of that sort. Then when we when we place that charge in the field, we have to find the force per unit charge on it, and that will give us the value for the electric field strength. Then if we use the definition of electric field strength for a point or a spherical charge, we can get the force to be equal to force equals Q1 Q2 4 pi epsilon O r squared. So this is also something that we have discussed by now. So, and also you need to remember this. Then the electric field strength E due to the charge Q1 at a distance of r from its center is force divided by test charge, right? Then force is Q1 Q2 4 pi epsilon O r squared divided by test charge is then Q2. Then Q2 to Q2 gets cancelled out. As a result, we get Q upon 4 pi epsilon O r squared. E is the electric field strength due to the point charge Q, right? E is the electric field strength due to the point charge Q. So here we are talking only about the point charge. So it depends on the point charge. R is the distance from the point, right? Field strength is not constant because when R decreases, because you can see that here it is R squared, it decreases as the distance R increases. That is something that you have to that you can take from the equation, right? Then field strength once again obeys an inverse square law with distance, just like the gravitational field strength from a point mass. That is, further away you go, lesser is the effect of gravity. The field strength will decrease by a factor of 4 when the distance from the center is double. That is what the inverse square law would suggest, right? Because force is a vector quantity, electric field strength is also a vector, right? Electric field strength is also a vector. We have to give its direction. That means you naturally should remember that we have to use positive or negative signs, as well as its magnitude in order to specify it completely, right? So then we will look at this worked example, then we will find out the details. So you have to remember F equals Q1 upon Q2 4 pi epsilon O r squared, and then E equals Q upon 4 pi epsilon O r squared. So let's look at the examples that they can give, the questions that they might give. A metal sphere of diameter 12 centimeters is positively charged. The electric field strength at the surface of the sphere is 410 to the power 5 volts per meter. Draw the electric field pattern for the sphere and determine the total surface charge. So this is the electric field pattern away from positive, right? So it's a point charge, just like what I drew earlier. I hope it makes sense to you. So here another important thing that you need to do is the diameter has been given as 12 centimeters. Okay, so it has to be converted into meters, and also you have to understand it is diameter that has been given. So we drew the electric field pattern. Then remember, all of these field lines must be normal to the surface and radial, and also remember all of these field lines should meet at the center. So it should be concentrated at the center. Then the quantity is given. They have given E, electric field strength, E equals 410 to the power 5 volts per meter. Then radius has been given, right? It is the radius that we need to consider. I told you that it is diameter they have given, so we divide it by 2, and we have to obtain it in meters. Then it is going to be 0.06 meters. Then we have to use the values that they have given in the equation. So we have to use the equation E equals Q upon 4 pi epsilon O r squared. Then we don't need, we have the value for E, we need Q. Then Q is equal to E multiplied by 4 pi epsilon O r squared. And then 4 pi are constants. Epsilon O, we know that it is 8.85 10 to the power minus 12. R squared is 0.06 squared into 4 into 10 to the power 5. And as a result, we will get 1.6 into 10 to the power minus 7 coulombs. That is the charge. Then you can convert it into 0.16 microcoulombs. I hope you understood. After the note is done, you will have to do the questions, question 1 and 2. Let me give you a note first, and after that we will move on to the next lesson. Write down. Practical investigation of Coulomb's law. Two spheres of polystyrene coated with conducting silver are attached to perspex handles and are given a positive charge. As shown below, one ball is placed on an electronic balance and the other on a movable platform. When the movable ball is brought closer to the other ball, as the inverse square law has suggested, there would be an increase in the force, resulting in a new higher reading being given by the electronic balance. Leave a line and write. Difficulties. The charges can be lost to the air or the connected materials, and the force is small. So the measurements can be difficult. Right, so those are the problems. Yeah. Right, then write down electric field strength for a radial field. I'm not going to give you the definition for electric field strength because we have already studied that. But if you feel that you should write it down, you should write it as the electric field strength at a point is defined as the force per unit charge exerted on a positive charge placed at a point E equals F upon Q. Then write down the force created by a Q1 point charge Q1 point charge on a Q2 charge placed in its field. Q2 positive charge placed in its field can be calculated as follows. The force between the leave a line and write. The force between the point charges is given by F equals Q1 Q2 divided by 4 pi epsilon O r squared leave a line, because electric field strength E is equal to force upon test charge, force over charge, E equals force upon test charge. So the force is Q1 Q2 divided by 4 pi epsilon O r squared, then that is divided by Q2, right, test charge. Then it becomes Q1 Q2 upon 4 pi epsilon O r squared Q2, right. So you have to write down this part, okay. And Q1 to Q2 to Q2 gets cancelled out. As a result, you get Q upon, Q is the point charge, Q upon 4 pi epsilon O r squared. So as you can see, it does not depend on Q2. Right? So that is the equation. E equals Q upon 4 pi epsilon O r squared. Highlight it. That is the equation for electric field strength. I hope you understood. If you have any questions, please raise them. Then I will discuss them.